Turkey continues to demonstrate rapid progress in its defense and aerospace industry through the development of various modern platforms. One significant achievement is the production of the TAI Hurkus turboprop trainer aircraft, a symbol of the country's aviation technological independence. This aircraft was developed by Turkey's national aerospace company, Turkish Aerospace Industries (TAI). The Hurkus program was initiated with the aim of meeting the Turkish Air Force's need for basic to advanced training aircraft while reducing dependence on foreign products. The assembly process begins with the fabrication of the aircraft's main components, such as the wings, fuselage, and tail. The materials used are generally high-strength aluminum alloys and composite materials to reduce the aircraft's weight without compromising structural strength. Each part is manufactured with high precision using CNC computer numerical control machines. After the main components are complete, the next stage is fuselage assembly. The structural panels are assembled using modern riveting and bonding techniques. This process is carried out in stages on the production line, with each workstation assigned a specific task. Technicians ensure that every connection is strong and meets aviation safety standards. Once the main structure is complete, the aircraft enters the system integration phase. This is one of the most complex parts of the assembly line. Various critical systems are installed, such as the electrical system, hydraulic system, fuel system, and digital avionics. The Hurkus cockpit is modernly designed with multifunctional digital displays. The next stage is the installation of the turboprop engine, propeller, and landing gear. The engine is the heart of the aircraft, so its installation is carried out under strict supervision. After that, the wings and tail are attached to the fuselage through a very precise alignment process. Small errors in alignment can impact stability and flight efficiency. Once all major components are installed, the aircraft enters the finishing phase. The aircraft's surface is re-inspected and then painted using special techniques to protect against corrosion and provide visual identity. The paintwork must also take into account the additional weight to avoid impacting the aircraft's performance. The TAI Hurkus aircraft is a clear example of Turkey's aerospace technological advancements. Developed by Turkish Aerospace Industries, TAI, the Hurkus not only serves as a training aircraft, but also incorporates a variety of advanced technologies that enable it to compete globally. The Hurkus is designed with an optimal aerodynamic structure for stable and efficient performance. The wing and fuselage shapes allow for smooth maneuvers, crucial for pilot training. Furthermore, the use of composite materials and lightweight aluminum alloys makes the aircraft robust, yet fuel efficient. The design also prioritizes pilot visibility, with a spacious canopy providing maximum all-round visibility, a crucial feature for basic and advanced flight training. One of the Hurkus' key features is the use of a glass cockpit, a digital cockpit system with multifunction displays. This technology replaces traditional analog instruments, allowing pilots to access a variety of real-time flight information on a single, integrated display. This feature makes the Hurkus ideal for training pilots who will eventually fly modern fighter jets, as its interface resembles that of the latest generation jets. The Hurkus is equipped with various advanced safety systems, rarely found in training aircraft of its class. One of these is an ejection seat, which allows the pilot to eject from the aircraft in an emergency. Furthermore, the aircraft has an automatic engine and avionics monitoring system. If a problem occurs, the system provides early warning to the pilot, minimizing the risk of an accident. The Hurkus is named after Turkish aviation pioneer Vecihi Hurkus, a key figure in Turkish aviation history. The project was officially launched in the early 2010s, with its maiden flight taking place in 2013. From the outset, the Hurkus was designed to meet international standards, including civil certification from the European Union Aviation Safety Agency (AESA). This makes the Hurkus one of the few military trainer aircraft to also have civil certification, opening up export opportunities to various countries. Hurkus aircraft are manufactured at TAI's modern facility in Ankara. This process involves various stages, from airframe structural assembly and avionics system installation to quality and safety testing. The aircraft uses efficient turboprop engines and is equipped with advanced digital avionics. Its cockpit features a glass cockpit concept, allowing pilots to train with technology similar to that of modern fighter jets. Furthermore, the Hurkus is equipped with safety systems such as an ejection seat, which is rare in training aircraft of its class. The Hurkus capabilities extend beyond training and can also be used in light military operations, such as patrol, reconnaissance, and tactical support. This flexibility makes the aircraft attractive to countries requiring a multifunctional platform. With low operational costs, the production of the Hurkus has had a significant impact on Turkey's domestic industry. The program has fostered the growth of an industrial ecosystem, including local component suppliers, a skilled workforce, and technological research and development. Furthermore, the Hurkus success has strengthened Turkey's position in the global market as a military aircraft manufacturer. Several countries have expressed interest in adopting the aircraft as part of their training systems. The production of the TAI Hurkus represents a strategic step for Turkey in building its aerospace industry self-sufficiency. With its modern technology, multifunctional capabilities, and international standards, the Hurkus not only meets domestic demand but also has significant potential in the export market. This success demonstrates that Turkey is capable of competing in the global aviation industry while paving the way for the development of other advanced aircraft in the future.